In this video, we talk about function operations and composition. Let's start with the following notation for function operations. If we have two functions f and g, then we can define the following operations. F plus g of x, this denotes sum of two functions f and g, so this can be written as f of x plus g of x. So this is sum function, and we have similar notation for the difference. So this is f of x minus g of x, so this is difference function. And the third notation is the multiplication or the product. It's f times g of x, it's f of x times g of x. This is product function. And the division or the quotient is f over g of x is f of x over g of x, provided that the denominator is not equal to 0. So this is the quotient function. So this is the notation that we will deal with in this section. For example, if f of x is given by x squared plus 1 and g of x is 3x plus 5, we want to find first f plus g of 1. Instead of writing it in terms of x, we want to substitute 1. So we use the notation. So the notation says that f plus g of x is f of x plus g of x. Similarly, f plus g of 1 is f of 1 plus g of 1. What does that mean? That means we plug x equals 1 into f. So this is 1 squared plus 1 plus. Now g of 1, we plug 1 into this function, the function g, and then we simplify. 2 plus 3 plus 5, that is equal to 10. Number 2, we want to find f minus g of negative 3. This is the second notation, the difference function. So this can be written as f of negative 3 minus g of negative 3. So we substitute negative 3 into f, we get negative 3 squared plus 1 minus. Now we substitute negative 3 into g, we get 3 times negative 3 plus 5. Now negative 3 squared is 9 plus 1 minus negative 3 times 3, negative 9, plus 5, this is negative 4. So this is equal to 14. Now if we ask you to find f times g of x or of 5, let's use 5 or substitute 5. So this is f of 5 times g of 5. Now we substitute 5 into the function f, we get 5 squared plus 1 times, now substitute 5 into g, in the function g, we get 3 times 5 plus 5, this is 26 times 20, this is equal to 520. Now the quotient, we want to find f over g of 0, but this is equal to, now using the fourth notation, f over g of 0, it's f of 0 over g of 0. f of 0 is 0 squared plus 1 over g of 0, 3 times 0 plus 5, and this is 1/5. Let's take another example. If f of x equals 8x minus 9 and g of x equals square root 2x minus 1, we first find f plus g of x, and then we find its domain. Okay, so to find this, we first find f plus g of x. So this is f of x plus g of x. But f of x is 8x minus 9 and g of x is square root 2x minus 1. We can't simplify, so we just leave it in this form. Now we want to find the domain. For the domain, this part doesn't have any problem because this is polynomial. But the second part, the square root, this is only defined for non-negative inner function. So we want 2x minus 1 to be greater than or equal to 0. And then we solve this inequality. We add 1 and then 2x greater than or equal to 1, and that means x is greater than or equal to 1/2. So greater than or equal to 1/2, that means to the right. So using interval notation, we can write it as 1/2 to infinity. This is the domain of f plus g of x. Now, one of the very important formulas is what's called difference quotient. This is very important in calculus. So this formula is given by f of x plus h minus f of x all over h. So if you are given f of x equals 2x squared plus 3x, and you want to find this expression, in this case we substitute x plus h here. So let's first find f of x plus h. This is 2 times x plus h squared plus 3 times x plus h. Now we simplify. 2 times, we need to expand this expression, but we know that a plus b all squared is a squared plus 2ab plus b squared. So we apply it here. So x plus h all squared is x squared plus 2hx plus h squared plus. Now we distribute 3 on this parentheses, so we have 3x plus 3h. Now distribute 2 on this expression inside the parentheses. We get 2x squared plus 4hx plus 2h squared plus the x plus 3h. Now let's try to simplify. Can we simplify more? We have 2x squared here. We don't have another expression with x squared. We can't simplify more. So let's substitute into the formula. So the formula says f of x plus h minus f of x over h. Now this is equal to f of x plus h is this expression. So 2x squared plus 4hx plus 2h squared plus 3x plus 3h. This is f of x plus h. Now minus f of x. What is f of x? The original function, it's 2x squared plus 3x all over h. So this is f of x. Now we simplify more. So this is 2x squared plus 4hx plus 2h squared plus 3x plus 3h minus, now we insert this negative sign into this expression, so we get negative 2x squared minus 3x all over h. Let's see if we can simplify more. We have 2x squared, negative 2x squared. We have 3x and negative 3, so we can cancel them. And we can take h as a common factor. We have h here, and h here. And in the denominator we have h, so we can take h as a common factor. From this expression we are left with 4x. From this we are left with 2h. From this we are left with 3 all over h, so we cancel h. We get 4x plus 2h plus 3. Now that was the notation about function operations. Now let's talk about composition of functions. Composition of functions. And we may talk about the domain in this context. So the composition means that if we have two functions, the function f defined here and the function g is defined here, we use different color for g. The elements here are x, here f of x, and here we want to move from f to g. So instead of going from the set x to y and then from y to z, we start at x and end at z directly. So what we do here is that we substitute. Now here under the function g, we find the value of the function under the function g. So we substitute f of x into g. So we first substituted x into the function f to get f of x, and then we substitute f of x into g of x to get g of f of x. This is the composition. So instead of doing all these steps, we start here. This is g of f of x, or we use the following notation: g circle f of x, where this is read g of f or g compose f. Now we can imagine this as a machine. So we have input x and it enters the machine. The machine processes this under the function f. So it processes this x, this input, using the function f, and then we get f of x, and then this will be inserted into another machine. So it will be processed under g, so we get g of f of x. This is the output. Let's take some examples. Let f of x equals 2x minus 1 and g of x equals 4 over x minus 1. We want to find f compose g of 2. So in order to do this, we need to remember that f circle g of x is f of g of x. This is the inner function. So you need to remember this, how to write this using this notation. So we have same thing here, f circle g of 2, or f after g. So here we need to write it this way, f of g of 2. So we start with this expression. So we find g of 2. G of 2 is 4 over 2 minus 1. We substitute it here, and this is inside f. So we get f of 4 over 1, and that's f of 1, f of 4. Now f of 4, we need to substitute it into the function f. So this is 2 times 4 minus 1. This gives 8 minus 1, which equals to 7. Second, we want to find g circle f of negative 3. Applying same formula here, this can be written as g of, this is the outer, this is the inner, g of f of negative 3. So we start from this inner function, f of negative 3, we substitute negative 3 into f, so we get 2 times negative 3 minus 1, and this is negative 6 minus 1, negative 7. So we have g of negative 7. This expression is equal to negative 7, or this number is equal to negative 7. So now g of negative 7 is 4 over, we need to substitute into the function g. So we have 4 over negative 7 minus 1, and that's 4 over negative 8, which equals to negative 1/2, which is equal to negative 1/2. Now let's focus on the domain of these functions. So if we have the function f of x equals square root x, and g of x equals 4x plus 2, and we want to find f compose g of x. So to find this, we make this equal to f of, this is the outer, this is the inner, so f of g of x, and this is equal to f of, what is g of x? G of x is 4x plus 2. And now we need to substitute this into the function f. So the function f is square root x. So square root of x. X in this case, we need to substitute 4x plus 2 for this x. So we get 4x plus 2. We don't need parentheses here. So that's the composition of f and g. Now if we want to find the domain, what is the domain? The domain of this function, new function, is that since we have square root, that means this is defined when the inner expression or inner function is greater than or equal to 0. Now we solve for x. We get 4x greater than or equal to negative 2, and then divide by 4 both sides. X is greater than or equal to negative 1/2. So this is negative 1/2 on the number line. Greater than, that means to the right. So the domain is negative 1/2 to infinity. This is the domain. Now let's find g circle f of x. So let's find G compose f of x. Now we apply same formula. This is G of f of x. Same notation. Now what is f of x? F of x is square root x. Now we substitute this into the function g, but the function g is 4x plus 2. It's 4x plus 2, but here we substitute square root x. So we get 4 square root x plus 2. Now what is the domain in this case? The domain of this function is, we don't have any problem here. We only have problem with the square root. The expression inside the square root should be greater than or equal to 0. So in the number line we have 0 here, greater than to the right, and that means the domain is 0 to infinity. Let's do another exercise. F of x equals 6 over x minus 3, and g of x equals 1 over x. Let's find f compose g of x. So to find this, we write it as f of g of x. And this is f of what? What is g of x? G of x is 1 over x from here. And then we substitute this into the function f. This is the function f. So we have 6 over, instead of x, we have 1 over x minus 3. Then we simplify, we try to get a common denominator here. So we have 3 over 1, and then we multiply it by x. This gives 1 minus 3x over x, and then we flip the denominator, we get 6x over 1 minus 3x. Now this is f compose g, or f of g. Now we need to find the domain. What is the domain? The domain, we look at this expression, and for this expression we only have a problem with the zeros of the denominator. So we need to find zeros of the denominator. So we set the denominator equal to 0 and find the value of x here. So let's add 3x. 1 equals 3x, and then divide by the coefficient of x to get x equals 1/3. So when x equals 1/3, the denominator becomes 0, and that's a problem. So we need to exclude this. So the domain is everything except 1/3. So on the number line, we have 1/3 here, it's open circle, and everything else is defined. So we can write it this way: negative infinity to 1/3, union 1/3 to infinity. But we still have a problem. We still have a problem with the function g of x when x equal to 0. So we need to exclude except 0. What should we write here? So let's do the number line again. So we have 1/3 here, and 0 is here, and everything else is defined. So let's rewrite the domain. The domain is negative infinity to 0, open at 0, union from 0 to 1/3, it's open at 0, open at 1/3, union 1/3 to infinity, it's open at 1/3. Now we don't need this. And that's it. This is the domain. Now we have an important question here. So the question is f of g of x, or f compose g, is equal to g compose f of x? The answer is, by looking at the previous problems, let's see if we solved one problem with f. Yes. Here for this exercise we found f compose g, and that gave us square root 4x plus 2. And when we compose g and f, I mean g compose f, we got a different function, 4 square root x plus 2, and those are different. That means this is not true in general. So not true in general. What does that mean? Not true in general, that means there are some cases where this is true. True for some cases. We'll talk about this later, but I'll just want to mention here that if f circle g of x is equal to g circle f of x, that means f and g are inverses of each other. Those are inverse functions, inverses of each other. So now let's take another example. Let's take an example of this function. We are given the composition here, the composite of the two functions. It's x squared minus 5 all cube minus 4 times x squared minus 5 plus 3. We are given the composite of the two functions, and we are asked to find the functions f and g. Now, how to find these two functions? In order to find these two functions, we need to determine which one is the inner function and which one is the outer function. This function here is the inner function. The function g is the inner function. What is the inner function in this formula? The inner function is x squared minus 5. So g of x is x squared minus 5. Now, what is the outer function? The outer function is f. Now, the outer function here is this expression raised to the power 3. We consider this as x cubed minus 4 times this expression is x plus 3. So if we compose them, let's compose them. Let's find f of g of x. So this is f of, what is g of x? G of x is x squared minus 5. Now we substitute into the function f. We get x squared minus 5 cubed minus 4 times x squared minus 5 plus 3. And that means our answer